Introducing Secure, a digital twin platform for the built environment, which captures and displays sensory data from IoT devices, providing real-time insights into spaces. Secure allows for detailed information to be displayed comprehensively by offering map views of all linked devices and sensors, as well as graphs, heat maps, and even custom alerts and notifications. It monitors air quality, occupancy rates, water leaks, waste management, carbon emissions, and overall energy consumption, keeping any space in an optimal condition and supporting ESG requirements. Owners, managers, occupants, service providers, and even visitors can view all this information in real time at the click of a button on any device. Secure easily integrates with existing systems and devices, saving significant capital expenses. In-building assets can also be tracked and maintained, improving their life cycles. Centrally managing and running a digital twin is just the beginning. Getting real-time data on how a building or space is being used enables the provision of inspiring and engaging facilities to its inhabitants.
Hi, Mike. Thank you.
Hi, Kaushlesh. How are you?
I'm doing well. I'm really happy to be here.
Thank you. So I'll just do a quick introduction to Kaushlesh Chandel, which we'll call him KC, so I don't completely continue to destroy your name. KC spearheads innovation and research at Retransform. He has architected several customers and digital transformation journeys, including commercial real estate analytics, Salesforce, data warehouses, machine learning, AI, and migration to the cloud. Welcome.
Thanks, Mike. Okay, so I want to talk about like smart buildings, digital twins, and some of the use cases, and what are the things we can consider while setting up your smart building, even if you have already sensors and devices, or if you want to get started. I want to talk about what are the few important things we can think about. Mark has just explained the edge versus cloud architecture very well. So let's see what we can do with digital twin. So digital twin, think of it as it's just a visual representation of an asset. It was first made popular by NASA to understand physical objects using software-based simulation. So as you can see in this slide, it's a digital replica of the property, and you can visualize and understand air quality, energy consumption, occupancy level. You can have heat maps, and you can also capture events like water leakage or a door was left open. Then you can also use digital twin for things like indoor navigation, like finding the right breakout room during Realcomm, and or navigation for facility management. A technician can find the equipment within a property that he has never been to using 3D and augmented reality based navigation. So think of it as a digital representation of the property and all the data and information embedded within it. So let's talk about what are the benefits which we can pass it on to the customers, not only from property management. One of it could be transparency of air quality and sanitization information. Understanding the occupancy of spaces. A customer can know when a coffee shop is too busy or when it is not. Or it could be like finding the right conference room using augmented reality based indoor navigation, or even virtually visiting a place, virtually visiting a space like you go to Zillow and you see the house before going there. Similarly, a tenant or a customer can experience the space using the digital twin. Okay. Moving on. So what are the few important things we should consider before picking up the right digital twin technology, or what edge devices or technology? Mark did talk a lot about it earlier, so I'll try to keep it short. We should always think about security, SSL and TLS, whether the devices, they are all the data communication is encrypted or not. We should create a separate network with preferably a 4G or 5G failover. So if your network goes down, it has a failover option. Ability to control your devices remotely using some kind of VPN is also important. If you install, let's say you install 500 sensors, you don't want to be going to the individual sensors and fixing them. So ability to remotely manage them is important. Air gap is important. Byron also talked about it. So not only your IoT devices should be on a different network than your regular users, IoT devices should not also be allowed to access anything else. So you should set up firewall, a separate air gap network. So even if one device is compromised, your risk is still isolated. It doesn't spread across to other users of your Wi-Fi or your network. And okay, so so what should be on the edge and what should be on the cloud? Now, it's a long discussion. We can keep talking about it, but I would recommend a hybrid approach where we decide what do we want to offload to the edge device and not completely rely on cloud, but you need a hybrid approach. So having an IoT edge means everything necessary should be on premise. Like, for example, can your network pass this test? Turn off the internet. Will the smart building setup, will it still work? If it passes the test, that means you have the right setup of a edge-based technology. Turning a device like HVAC on and off should be on the edge. Automations like turning on the ventilation automatically, the logic and processing should be at edge, and it should not depend on the cloud. Then AI processing. Byron talked about earlier about the video feed. So if you want to process live video and count the people walking in, that should be processed on the edge. Sending it over the cloud will not only be expensive but also have security issues. So if you want to implement any AI, artificial intelligence or machine learning technology, that should be on the edge. And you should also think about proofing your setup, avoid vendor lock-ins, and from a building perspective, try to take control of your IoT setup. And have a good understanding how you are setting it up and be more flexible. Moving on to the next slide. So this slide, I just wanted to talk about what are the common technologies and which can be linked using edge data processing hub. These are like widely available and very easy to scale, and you can connect multiple buildings securely. So one on the left, Zigbee is good for battery powered sensors and also for controlling devices. Zigbee can create a mesh network so you can scale very easily. Then LoRaWAN is great for long distances. It can go several miles. You cannot send video streams over LoRa, but you can do simple sensor data like a on-off status or temperature of a building. Wi-Fi is our old trusty system, but edge gateways can automatically create a mesh, talk to each other, and it will automatically build and repair a secure network. So you can look for those edge-based Wi-Fi mesh technologies, and you can connect a building with 50 floors very easily using this mesh technology. Bluetooth is very good if you want to interact with if you want your tenants to interact with their mobile phones. So Bluetooth is good. Then VPN, and you should also consider about legacy system with the serial port and USB based technology when implementing. Thanks,
Casey,
Mike.
Just real quick, one question to kind of throw back at you. You know, a lot of this IoT sensors require some type of infrastructure, and in some cases the IT groups may not play very well with it. But if a building doesn't have any IoT infrastructure, what do you suggest is a good way to start?
I would. That's a good point. I would suggest that if there's no infrastructure, you can easily choose IoT edge gateways, which are based on cellular network, and they are very easy to set up. And so they will create its own secure network, and start by something like a temperature, humidity, air quality, and put sensors on the doors. So that's a good way to get started with IoT and reaping the benefits.
Great. I appreciate your presentation, and we already had some questions come in that I'll ask you later in the Q&A. Thank you.
Thanks, Mike.